Okay, now that we've actually performed the test and calculated the probability, what can we conclude? First, we must determine what is a low probability. R.A. Fisher, who's the father of statistical inference, thought that probabilities of 10% and higher were just not that low. He wasn't that impressed. He advocated using a threshold called alpha, and he liked 5%. He's like, oh, 1 out of 20, that works for me, or 0.05. By the way, this is just convention. He's like, 1 out of 20. Everybody said, yeah, we're good with it. And for a lot of statistical tests, we will use 5%. But you can adjust that to fit the situation because if it's like life or death, you really, really want to be sure, you might be using a different alpha. All right. Now, if the p-value, if the probability is lower than this magical window, which is called alpha, then it is a surprise to get this result. So we're saying anything lower than 5% probability, that's a surprise to us. That doesn't make sense if the null were true. Therefore, what we do is we reject the null hypothesis and state that there is convincing evidence for our alternate hypothesis. So that's kind of like rejecting the innocent plea and finding the defendant guilty. For example, zip ties and duct tape. If you're really innocent, what's the probability that you accidentally bought zip ties and duct tape right before a kidnapping that you're about to be accused of? Incredibly low. So this is the boilerplate that you can use to write your conclusion. If your p-value is lower than your alpha, we say because our p-value of whatever number you get is less than 0.05, we reject H naught or null. There is convincing evidence that the true proportion of whatever it is either higher or lower or just not equal to. All right. By the way, this 0.05, do we have to use 0.05? As I mentioned in the previous slide, we do not. It's just the convention. What if our p-value is higher than alpha? Well, if the probability is high, then it's not a surprise to get that result given that the null hypothesis is true. We basically fail to reject the null hypothesis and state that there is insufficient evidence for the alternative. Insufficient, all right? There's not convincing evidence. For example, I would ask a couple of my kids, how many of you bought zip ties and duct tape in the last couple of weeks or month? And invariably, I'd get 10 to 20% of my kids have bought zip ties and duct tape, usually for a physics project. Does that mean they have been assaulting and kidnapping people? No, we don't have sufficient evidence because the probability of someone just buying zip ties and duct tape in any given period is not that low. But buying zip ties and duct tape right before a kidnapping you're about to be accused of, that is low. So if it's just the probability is high, we fail to reject the null and state there's insufficient evidence. And here's the boilerplate you would use. Because our p-value of whatever it is greater than 0.05, we fail to reject H naught. There is insufficient evidence that the true proportion of whatever it is greater than or not equal to or less than. Now, you do not say, whoop, I thought I had it there. If you say that you believe H naught is true, by the way, you will lose points on the AP exam since we cannot make the conclusion. We can never prove innocence. We can never prove the null. All right, let's revisit our smoke detectors and make a conclusion based on the p-value we obtained. Well, we had a p-value of 0.0038. That's really low. That's less than 0.5%. So since that is very low, we're saying, ooh, okay, that sets off alarms. Haha, get the pun. It's less than 0.05. We reject the null that the true proportion of homes in the city with fire alarms is 0.90. There's convincing evidence that the true proportion of homes that have fire alarms is greater than 0.90.